Have you ever looked up at the night sky? I mean, really looked up. You see countless stars twinkling back at you, each one is a sun just like our own. Many of them have planets orbiting them. Our galaxy, the Milky Way, has hundreds of billions of these suns. There are hundreds of billions of galaxies in the observable universe. The numbers are staggering. So, with all that cosmic real estate out there, where is everybody? If the universe is so vast, why haven't we found any sign of intelligent life? Let's put the size of the universe into perspective. Imagine our sun is a single grain of sand. The Earth would be a microscopic speck of dust orbiting it a few inches away. This contradiction is the Fermi Paradox, named for physicist Enrico Fermi. Back in 1950, during a casual lunch with colleagues, aliens came up. Given the math, civilizations should have had billions of years to spread. Their signals, their structures, their spacecraft. We should see evidence everywhere, but we don't. We see nothing. Why do scientists feel so confident that life should be out there in the first place? It boils down to the ingredients of life and the sheer number of cosmic kitchens. These building blocks of life are not rare, they are everywhere. It seems the universe is pre-programmed with the raw materials needed to get life started. Furthermore, we now know that planets are not the exception, but the rule. Thanks to powerful telescopes like the Kepler Space Telescope, we've confirmed the existence of thousands of exoplanets. Many of these planets orbit within what we call the habitable zone, or the Goldilocks zone. This is the not too hot, not too cold region around a star where liquid water could exist. And where there's liquid water here on Earth, from deep sea vents to acidic pools, we almost always find life. The timeline of the universe also supports the idea of widespread life. A civilization could have arisen a billion years before ours. Think about that, a billion years. Compare human technological progress in just the last century to what a civilization could achieve with a billion-year head start. They could have developed technologies far beyond our comprehension, making interstellar travel as easy for them as a walk in the park is for us. The galaxy should be crawling with civilizations. So, if they should be there, why aren't they? Scientists have proposed many possible solutions. They range from the hopeful to the downright terrifying. One of the simplest explanations is the Great Filter. The filter could be behind us. The emergence of life might be incredibly rare. Or the filter could be ahead of us. Perhaps civilizations destroy themselves through nuclear war, climate change, or out-of-control artificial intelligence. Or they are simply too far away. Space is just too big to cross. Distances between stars are immense. Even at light speed, the nearest star is over 4 years away. Colonizing a galaxy could take millions or billions of years. Civilizations might rise and fall before they ever meet. They exist but are out of our reach, and we are out of theirs. Then there's the zoo hypothesis. Advanced civilizations are out there. They know we are here but choose not to contact us, observing us from afar like animals in a preserve. A prime directive of non-interference. Let us develop naturally, a protected cosmic wilderness, a do not disturb sign on our solar system. We are isolated and watched by silent, unseen zookeepers. Finally, a darker idea. Silence is survival. Imagine a dark forest of hidden hunters. Stay silent to survive. Shout and you reveal yourself to predators. The dark forest. The universe is dangerous. Instinct is to stay hidden. Naive broadcasters get eliminated. The silence we hear is the silence of fear. Each solution to the Fermi Paradox holds a mirror up to humanity and forces us to reflect on our own future. If we are truly alone, if life on Earth is a one-time cosmic miracle, then the responsibility on our shoulders is immense. All of it would be unique. If the Great Filter lies ahead of us, then the paradox serves as a grave warning. This would mean that our greatest challenges, climate change, pandemics, nuclear proliferation, are not just terrestrial problems but cosmic tests. We're on a great cosmic final exam, and if we fail, we become just another silent data point in the solution to Fermi's question. What if the zoo hypothesis is correct and we are being watched? If our cosmic zookeepers are benevolent, they might step in to save us from ourselves if we get too close to the edge of self-destruction. We might not be alone, just in cosmic daycare. Ultimately, the Fermi Paradox is more than just a question about aliens. It's a question about us. It challenges our arrogance and forces us to consider our long-term survival, our potential, and our responsibilities. We don't have the answer yet. But the quest to find it, the very act of looking up at the stars and asking where is everybody, is one of the most profound things we can do. It connects us to the cosmos, and drives us to be better, wiser, and more careful stewards of our own fragile world.